Alright, this is the first day of solving by elimination. Last week we learned how to do substitution, which a lot of you did a pretty good job on. But there are two systems that you use to solve, or two methods that you use algebraically to solve systems, and this is the second one. One thing we learned in algebra is that two opposites cancel out whenever we add them together. For example, when you add a positive 2 and a negative 2, they cancel, they go away, they make 0. Just like if you put a positive 6x together with a negative 6x, they add up to make 0. This property is going to help us this week as we learn another way to solve systems that we call elimination. Think about what elimination means. It means to get rid of something. And so think about how opposites actually eliminate each other, and these two eliminate each other. That is going to be what our overall idea is in elimination. But before we get to the details, let's consider what we've learned in algebra so far this year. We've learned that it's okay to add 5 to the left as long as you add 5 to the right. Think about how we used to solve systems. We had x minus 5 equals 11, and the way we did that was we simply randomly added a 5 to the right, but as long as we added 5 to the left, then it was legitimate. That was balanced. This canceled out, giving us x equals 16, and that was how we answered the question. We've learned that it's okay to multiply by 6 on the left as long as you multiply by 6 on the right. In general, what you've learned is that everything is legal as long as it's done evenly, as long as it's done to everything. So this is where our introduction will begin. Our job in elimination is to actually create our own sets of opposites. Now, I know that that word is scary for you. That means that you have the power to actually create opposites. We need to create two values with the same number but a different sign. Think again, it's not 5x and 5x to cancel out, it's 5x and negative 5x. It's not negative 3 and negative 3 to cancel, it's negative 3 and positive 3. And so you have to think that we have to create our own opposites. Fortunately, this is a very simple pattern to eliminate. It just takes a bit of practice. So right now we're going to start with just one term. So we're going to use algebra to eliminate this term. Here's all we have to do, and again, you can create this. We are going to take 4x and x and eliminate them. Eliminate that in general. So we're going to eliminate our x by creating opposites. From what I know, this can be turned into 4 by simply multiplying by 4. And again, that turns that into 4x and 4x, but these are not opposites. And so all I have to do is switch the bottom sign, put those two together. You of course get 0. They cancel out. It is that simple. I picked a number to multiply by that makes them meet, and then I simply switch the signs. That is all. 2 steps. That easy. You just have to make sure again that you take your time, that you take this seriously, and I think everything should be fine. It is as easy as the example makes it look, but you can see that it's legal to multiply by whatever number you would like. It is also legal to switch the sign at the bottom to get the job done. So let's look at a couple of examples together and just make sure you understand how easy this is just to do in general. If you had x and 3x, you can look at yourself and say, hey, x can be turned into 3x if I just multiply this by 3. That would make this 3x and 3x. But these don't cancel, so I now have to make this a negative 3x, which of course gives me 0 and cancels them out. Very simple. 8x and x. This works if x turns into 8x by multiplying by 8, so I put parentheses around it and put an 8 on the outside. This turns that into 8x and 8x, which in order to make these go away, I will turn that into a negative 8, and I end up with 0. Right now you're probably thinking this is way too easy to be what I think it is, but the thing is we're dealing with one term, and we're going to be dealing with more than one term, but the overall steps is just as simple. You just have to make sure that you are careful with what you are doing. It is a very simple process when one of the terms is just an x, but it's even as easy when both of them have a number. Watch this. 4x and 3x. 4 and 3 meet at 12 from what I know, which means I have to multiply this by 3 to make it 12. Have to multiply this by 4 to make it 12. But notice what I did. I simply took the bottom number and multiplied it up. I took the top number and multiplied it down. This makes 12x on the top. It makes 12x on the bottom. Switch the bottom there. You end up with 0. It's that easy. So here you look and say there's a 7 on the bottom, I'm going to bring it up. There's a 2 on the top, I'm going to bring it down. Both of these turn into 14x. Switch the bottom sign. You end up with 0. That is how easy elimination is. So when you get frustrated and you come up to me and ask for help and I don't, and I tell you that it's easier than what you think it is, it's because in general This is really what you're doing. The only thing is that you're going to be doing a couple of other things with it, and you just have to make sure your steps are right. So if you pay close attention, you notice that the number you multiplied on top is the same as the number attached to x on the bottom. So again, the number on top went to the bottom, the number on bottom went to the top. The number on top went to the bottom, the number on the bottom went to the top. You'll also notice that the number multiplied on the bottom is the same number attached to x on the top. It actually makes it much easier to do as long as you do not think too hard to make the numbers match up. So don't overthink this. And again, that's what you're going to hear me say when you ask me for help later. This is a very straightforward, simple process. You just have to make sure you take your time. Unfortunately, your problems aren't going to look like that. They're actually going to have 2 terms a day, but again, that's still not that bad. So now that we know how to work with one term, what happens if we add a y? Nothing much really changes except that when x eliminates, the y will still be around. So you're only eliminating one thing. It is also important to remember that if you multiply one term, then you must multiply all. That's the algebra I was talking about, as long as you do things evenly. Also, if you switch the sign on one term, you must switch signs on all the terms in that equation. So keep in mind the algebraic rule of as long as everything is balanced, then it is legal. So let's look at this and see how easy it is. Looking at these two, and again, focus on x's. 3x and x meet at 3. So what I'm going to do is put a parentheses around this whole thing, because I have to treat everything in this equation the same, and I'm going to multiply by 3 because I need this to look like that. I don't even think about the y, I'm looking only at the x's like I just did. Now rewrite the top equation because nothing changed. 3x plus 5y, and the bottom equation when I distribute turns into 3x minus 12y. Again, 3 times x, 3 times negative 4. But notice these two don't go away. I have to switch the signs, and here's what I do. Go to your bottom equation and switch everything in the bottom equation. Notice now whenever I add everything up, this goes away, but 5y and 12y make 17y. This is where you're stopping today. And as long as you can get that far, tomorrow should be very easy for you with just a couple slight changes in what you're doing. But again, I think it should definitely be in your reach because it's really not that bad. Look at B. 2x plus 3y, 5x minus 2y. Again, focusing only on the x's, there's a 2 and a 5. I'm going to bring my 5 up. I'm going to bring my 2 down because these two meet at 10. I'm going to distribute, and distribute carefully. 10x plus 15y. This makes 10x minus 4y. Notice that my 10x's don't go away because they're not opposites, so I have to switch signs, which means make this negative and make this positive. When I add these two things together, my 10x's do go away, but 15y and 4y make 19y. That's it. That is all you're going to be asked to do today. So as long as you've got that understood, again, you're just going to be waiting for the work and getting your lesson credit and all that stuff. Notice that nothing really changes except for how that you must do the distributive property now. This is the work that we will do to introduce the concept today. You're going to be asked to choose what's left over after eliminating x. It's not completely necessary, but for right now, please only switch the bottom row. Again, do exactly what I did. Do not switch the top row, only switch the bottom row. It's going to be amazing how many people come up to me and say, I got the wrong answer, and I'll say, well, because you switched the top row. Switch the bottom row, because all of my answers are based off of you switching the bottom row. So a quick peek at what's going on is here. It's just going to ask you to eliminate x. And so when you're asked to do that, you're going to simply do like we just did. 2x and x meet at 2. So I'm going to bring up my 2. Notice nothing's attached here, so I don't need to do anything. This turns into 2x plus 12y. This stays the same, 2x plus 7y. Well, with that said, these aren't opposites yet, so I have to switch. And my opinion, my recommendation for you is anytime you cross out a plus, please cross it out completely and put a little minus above it. That way you know that that's a minus and you don't read it wrong. Other than that, when you add these together, these cancel, and 12 minus 7 leaves me with 5y. That's your assignment today. Alright. 4x plus 2y, 3x minus 5y. Again, bring my 3 up, bring my 4 down, distribute 12x plus 6y. Distribute 12x minus 20y. 12x's aren't opposite, so I switch the signs on everything at the bottom. 12's go away. 20 and 6 make 26y. And that is what you will type into your MathXL whenever you get that far. But before you go do that, please hand in your lesson credit on this first, so that I know you at least have it understood, or that I know I need to talk to you in person to try to figure out what it is that you're missing. Now keep in mind, your lesson credit is part of your score, your daily score. So if you're not handing in lesson credit, you're getting a 0 every day. So again, make sure you are handing in the lesson credit, even if it's wrong. I don't care if it's wrong. You're not losing points if you miss the question. You are losing points if you don't follow directions and actually hand this in to me before you move to MathXL. So please do that, get that handed in, and as I said, once you're done, ask me, ask people around you. The bottom line is that you get it done, and remember that if you finish your MathXL early, you should go back and continue working on it, because if you don't, those low grades are going to hurt you for the whole quarter. You have until May 19th to get your MathXLs done, and you get 100% credit on whatever you get. But if you allow these things to stack up, it's going to be a very tough quarter. So other than that, like I said, hand this in, get it done, and good luck other than that.